Okay, so just to recap what we discussed in the previous sessions, we started with the basic CDS view creation in ABAP CDS views. We started with the uh, simple definition view, and also we have seen the joins and also filters, applying filters in CDS view definition. Also looked at the expression and then functions as well, some of the built-in functions. So we also have some examples given for date functions and etc. All the exercises are in uh, the Google Drive what I shared with you, so you can go through them for your exercise practice. Okay, today we're going to talk about some more other topics in serious view design. They are uh, the first one is to start with is aggregations. So aggregation terminology is very similar to what we see in native HANA or any of the data warehousing systems like BW, SQL data warehouse, and anything. Aggregations meaning uh, you are summarizing the data, or it can be summarizing or counting or minimize, maximize. It's just trying to group uh, data records based on certain characteristics. So those ones are going to be in group by, and whatever the aggregation you wanted to apply, you're going to put it in that apply in the aggregation class. So we'll look at some of the aggregations like sum, min, max, and also we apply the filter on the aggregated data using a having class. There's nothing difference between SQL with the CDS SQL in terms of having aggregations here. There are some changes going to come when using the aggregations, especially when you're using analytics query definitions with exception aggregation, and some of the bugs related things will come into picture. Those ones we will be talking or discussing in detail during the analytics part of it. But these ones are the standard aggregations what you see in SQL. Um, then we'll go to the next topic after. Okay. The first one to start with is aggregations. I'm going to talk from the finance model. This is going to be a basic aggregation. I'm going to use sum. That's going to be the basic one. Most of the time, we're going to use um, summation as the aggregation as the default behavior. And this is a function, an aggregate function I'm using here. You say that this sum of TSL is a column which is used for balance. This is an aggregation on specific column. There is a annotation for doing aggregations, sum, min, max on a specific column for analytical purpose or view annotation purpose. That's something different. We're not talking about those semantics of aggregations, just like what we see in calculation views modeling, where we define an aggregation. This is not an aggregation, but this is I'm talking about a function of using an aggregation here. Okay, I'm going to just copy paste this one and go in there to my uh, about perspective. I think I got out of the system, so I'm going to log in back and choose my favorite packages. Choose the basic ones. Still, I'm going to be doing this example in the basic series. This is a folder structure. This is nothing uh, uh, important at this time. The folder structure is to organize it. So I'm going to go to the core data services and say I can actually do the data definition folder, because I'm not doing any other type of core data services. I'm just going to do another data definition. So I can choose the data definition folder and say new data definition. And I'm going to say this one as aggregation. Okay, aggregations. I will say ex1, example one. So I could just put the name and say next. Use the same transport request, and then going into the, I can choose the template, the default template, or I can define my own. So I'm going to switch off this one and say finish it. What I'm going to do, I'll put the copied code in the window, and then I'm going to write my according to my requirement. This is taking a little time after a while. Okay, I'm not sure what's taking time. Yeah. Okay, I'll just paste this one in the bottom, and then I can write. So these annotations are no different from anything from the past. So I'm going to keep the same. I'll be changing my SQL view as AGZ example one, something like that. And I can remove these ones. So what I'm defining a view view name, which is going to be the one I just used as the data DDL source. That's going to be ex1. I wanted to make sure my serial data source name is same as that one, and select from my aggregate table, and then just going to describe the columns. While I'm doing the columns, instead of giving the in the direct column name, I wanted to apply another function called aggregation. So it's kind of another function like concatenation or any of the date functions we've used yesterday, string functions. Aggregation is also another function. So let me do that function and then use that. And then after that, it has to be group by. So the group by is going to give you aggregation level of characteristic. So if I'm going to use just account without profit center, this get grouped by account. So basically in general SQL, whatever the columns you're using in the select, you will have to put them in the group by class as well. You cannot have two columns here and then have one column in the group by. So if I'm keeping these two columns, I'll have to keep these two columns in group by as well. Okay, that's it. I'm just going to give these two columns as group by class, and that's it. I can end with the colon. I'm going to remove this one. It's a very simple group by. Say activate it, and you can just display the data, and it is going to be per account and profit center combination. The balance will be summed up. Okay, so just go to context menu and say open with data preview. You'll see that the combination of each account and profit center, the balance is summed up. So you can also do a group by just account. So what you can do is remove the or comment it, and then just going to remove this one, and then actually sorry, this one is going to be there, and then group by account, and then you can remove this one and also just comment this one. Okay, just going to be commenting it, and then say activate it. That's it. It's activated. Now can display the data. Open with data preview. Just by account level. So you also have, if you wanted to filter data on aggregated data set, you have to use having by. For example, you wanted to apply a filter on balance, not the balance column itself, but the aggregated value of balance column. Then this is what it is, and then you have to use it by having by. So you can do that. So if you do just where clause on the balance, it is going to filter on the balance column itself or the TSL columns. This is not what I wanted. I wanted to apply the filter on the balance aggregated value itself. You can put that in a having by clause and apply, say, okay, having by balance which is greater than 10,000, it's going to apply the filter on the aggregated data set and going to show you some like that there. Okay, that's one thing. What an example for aggregations, and I'm just going to look at if there is any one for aggregation. I don't think I have anything. Another simple aggregation behavior to show you a minimum amount and maximum average. There are several different aggregation functions I've used. Also have added some more semantics to the data column. So we're going to look at that as well. This is an example too for aggregations. Select the data definition and then going to say new one. And so aggregation, I'm going to say the same thing and just name change to ex2, and then I say aggregation example 2. Okay, and say next to it. So next, and I don't want any template. I'll just finish this one. I'll put the code in the bottom, and I can just take. Okay, these two annotations have no difference. They are mandatory ones. I'm going to keep it there on the top. I will change my CDS SQL view name. These are the repeated ones, so I have to do all the time. Aggregation AXE2. And then I'm going to defining. This is now I started using a different model. There is a EPM demo model. What we have got. Uh, this EPM demo model is being given for Shine content generally. So you have tables for sales order, purchase order, business partner. All the master and transaction data tables are given by SAP. They all start with SNWT, and then sales order is S4. I can show you those tables where they are so that you can use them. Um, you can also easily find them, the package where it is. I will see how the packages will be found from the table or the DB view or SQL, any of the SQL view. From the definition of the SQL view, we will be able to find the package of it. We'll come to that. So I'm going to just say select from, actually, I have to define my view, which is going to be uh, just the one I have done. And then I say ex2 as my source, saying select as select from SNWT underscore S4. And then I'm going to keep all the columns which have to be represented in there. So I'll say this column, this is going to be key GUID, that's the technical graphical user ID for the column. And then currency code. Currency code is a column. You can find it. If you say control space, it's going to list out all the columns in that particular for particular thing. So I don't want to know it, then just type in first two letters and then do the code completion with, and then you will get to the point, to the column easily. So I'm saying before this particular column, I wanted to give the label to it, the name of the column. So for that, now you can actually say end user text label, the same annotation what you have just given at the view level, you can also give there. That's going to be labeled as a description for the column. It is not a column name. If you wanted to have the column name, you can say as currency code, and this is going to be your um, this is going to be your currency, this is going to be renamed or used as a currency code column in everywhere outside of this view, and the label is a text for this particular column. I'm going to say same name, currency code, and then I also wanted to add another semantic annotation, which is semantics, saying that it is identified as a currency code column. You know that, right? If in above, for example, net WR is an amount field, and there is a currency key column always associated to represent the currency. So something, this is a currency key, what you're representing for currency code, and then amount you will associate this currency code column. The same way how you define in SC11 with amount and currency columns definition. Okay. So now next one is my gross amount. So I'm going to say at the rate of, sorry, I'm going to get the gross um, and then get the column name automatically. And I just wanted to add an aggregation function to it, sum of gross amount as um, gross amount total. Can give this name. If you wanted to add a label to it, you can still do the label to it as well. I'm not adding any label to it. I'm just going to leave that as it is. I just gave you a simple uh, an example to give the label to your column level versus your view level. Okay, but I still wanted to give a semantics to it. As I said, I wanted to add this as a currency amount. Well, for that, I will say semantics dot amount, and then you can see currency code. That's going to be, it always comes in the code completion. You're going to choose that. Okay, currency code. And then what currency column it has to be used. So you're going to display, you're going to give the one which you just described above for as a reference column to it. And that's it. This is my currency key columm. I annotated with the semantics currency code key. And then I have given that currency code as a reference column to my amount column. This is going to be with annotated as amount currency code. So this is how metadata is used with annotation definition. I can also have defined these other ones by just copy and paste. You can do that. I just wanted to make currency code as well, so that I don't have to rename it. That's fine. I can rename it. I'll just copy paste everything from there. Okay. Only difference thing I have to make sure is I'm going to remove the underscore and say because I changed something there. Similarly here, this is what I named it, so I'm just making a change to it. Code, and all good, and that's it. This is going to be currency code. So I defined all these columns, min, max, and control tab. Sorry. Let it be. I don't know. This is indentation. Anyway, so this is going to be your some of the columns with minimum and maximum and average and also count star as just to get the count of it. And then I grouping by buyer because that's what I used in the key column. So this is okay. I'm going to say activate it. So there are errors looks like. So we're going to look at the errors there first. Oh, so there is a code in the bottom. I forgot to remove it or remove that. And then it is still saying another error, just called the column currency code is unknown. Okay, that's something. Okay, it is defined as alias in this place, but it is not known. So I have to just make sure I'm giving the same column name because this is not defined The column name I'm using in the group by class has to be the column name of this column. This is alias which cannot be understood for group by class at this time of. For the next place in the next CDS or wherever it is using further, it is going to be used. Okay, so activated. It's activated, and I'll go to the digital display. Okay, it's at my mouse problem. I think I'll have to change data preview. You see that the gross, minimum, max, and average amount is being, uh, and you don't see the amount currency code associated to those amount columns, because this is not an analytical tool which can understand these currency annotations associated. So if you're going to run this query in the analysis office or RSRT, any of the reporting enabled tools, you will be seeing the currency code associated to those amounts. We'll see that in a later point in time. Okay. That's about the aggregations and some of the syntax we have added to the currency we have understood here. And also, we can also give the end user text for column. So all these annotations, what I'm giving inside the CDS view are field level annotations. And annotations where I'm giving on the top of the CDS view is the view level annotation. That's the difference between these two levels. And I'm closing these ones. Going into the next example, which is going to be having clause. I don't think I have to show you having clause, but I just explained you can apply the filter on aggregated value with using having clause. So you can try that one. There is an example for that in 6C. Uh, so I'll go back to the next topic, which is going to be data set operations. I don't know, this is a interesting topic. If you're familiar with the SQL, you know it very much better than any other topic. If you're from another data warehousing background, also you will be knowing about data set operations. So data set operations are union, intersect, minus. These are the some of the data set operations represented in general SQL. So you can have the joins or data set operation. So from the performance perspective, data set operations are much um, better than the joins. I don't know if you are familiar with the BW concepts. There used to be some objects in not a used to be, there are some objects in BW system with multi-providers, composite providers. And all the time they say multi-providers and info sets, I think, in the past. So multi-provider is always good for performance, and info set is not good for performance. That's what they just tell, and they don't give enough. They do give good information from the SAP, but in general, we don't really go into the C and why it is not. So in general, multi-providers are union. It's just going to combine two similar data sets for the output, and then InfoSet is a join. So it is going to make a join to the other data set. It doesn't have to be same or similar structures in these two data sets for making a join. So join is super flexible. It can go to any complex logic derivation. And union is not a super logic derivation object, but it can do a lot of performance benefits to you for combining the data set. There are limitations. Of course, you have to have a similar structures or similar columns asked as a data output for the unions. So if I have to tell you how we describe the data set operations in general, you go into take a look at a very simple diagram explanation in this blog. It's a very nice one. What I've really understood, and this is from the native HANA, but you can also understand from the concepts of native HANA into S4 HANA. The same concepts apply here. So this is the sets Venn diagram. You can understand this is the one which is everything is union, okay, and one in between these two is intersect. That's called intersect um, in data set operation, and one which is only in set one is minus, and if you do the other way it is also minus only to get the set two. So this is how SQL representation for data set operations does. You can do also achieve these data sets using joins, but as I said, uh, if you are able to do these ones with data set operations, better to do with data set operations. The reason for it is union and data set operations are much flexible in performance. You don't have to go into the joins. So better as long as you are, if you can do your requirement with union, just go for it. If you cannot do with your union or data set operations, there's a place when you go into the joins. So in this document, we don't use any joins, but we'll try to do everything exclusive, not exclusive. But anyway, the prerequisite for having this union setup is to have a similar data sets. Like, not exactly same also, but at least similar columns you're going to ask as an output. If you don't have another column from other data set for, you'll have to go, you don't get any results out of it. It's going to mismatch it. So you say that this is the elements, this is union, simple union, and there is a which elements exclusive to set one, and then you see ABC, and then this is only in set two, and then sure in both sets, which is going to be intersect. Okay, there is an intersect. So this is very commonly used ones in SQL, of course in native HANA SQL as well. You can also do them using union operations. The same intersect can also be done through union. Both are data set operations. You don't alternatively you can do with joins, but I'm not going to interfere anything with joins. So right now we don't have any of those non-exclusive minus and intersect operators in series. So you're going to use union, and you will be using union for all these solutions. So if you go through this document, in this document it says an alternative SQL solution with union for every operation. For example, except is only to get the one in one of the data set. You can simply achieve with except. The same requirement you can also achieve with your unions. So we're going to talk about four different operators here in native SQL using intersect, minus, union, and uh, minus, except, but all of them can be achieved with union as well. So union right now within CDS they didn't give all these operators like except, minus, intersect, anything. They just gave you union. So you have to go to the alternative SQL solution, which is defined for union, and then apply that in your CDS view. Okay, so don't you know how you use these operators, but anyway you cannot, since you cannot use those operators directly in CDS SQL, but you use an alternative SQL solution with union in CDS view. That's what I wanted to give. So you can achieve any of those four scenarios what defined in data set operations, or when these ones in CDS view in terms of union. Okay, and then so now we're going to take a look at these ones. There are some examples I have given to make it union for you. So union and union all. I think I'm using union here. So union all is if you wanted to allow the duplicates from the two different data sets. For example, there are could be some elements or records could be same in both places. So in those cases, you don't want to represent both of those records which are in same value, and then you can say just union. It removes the duplicates. So you're going to use union all. It's going to represent duplicates as well. So okay, I will be copy paste this example. I'm giving a basic example, but as I said, if you're interested, do all the minus, intersect, and whatever the functions we have seen in the document we just shown, which is seen with union statement. You'll have to tweak a lot in order to get that. It's going to give a simple union. You may have to apply some filters to it and some aggregations to it in order to achieve minus and intersect, etc. So you will be doing union plus those extra calculation to achieve the other data set operations. Okay, but native HANA SQL, you don't have to do that. You just go and use those minus intersect operations. And in the latest versions of native HANA, you got them given in even calculation view modeling as well as part of nodes. So they just make awareness among these tools and then try to have a solution some in one of the other ways. Okay, could I create a new data definition? I'm going to say name it as, this is going to be union example. I'm going to say ex1 union example 1. I'll say next. See, the my whatever the examples I'm using, you have to know one after the other, so that when the time comes, you will be using all of them together in the bigger CDS view, so that so the functions you'll be using, if you look at the standard CDS view, you'll be using functions, case expressions, arithmetic expression, date functions, system date functions, string functions. You use them a lot of all these things, joins, everything we are looking at individually with a exercise objects, you're going to put them together in the bigger one. So don't say that it is something training happening, but assume that you're understanding this concept together, and when you go to the bigger one, you're going to put them together there. So it's going to be the definition of the view. Will say I, there is no case sensitive, it is all automatically going to take your uppercase, so this is fine. uh, say union example 1 and union. So this model I'm using as flight in this case. So I mix up these different data models for our own understanding. So I'm saying define view, and I'm going to give the same name as what I have given as the DDL source. This is going to be union. Um, okay, ex1, and select from as customer table. So ID I'm defining as a key, and name, city, country, and I'm defining a type as customer. This type is a newly derived column from this data set. And there is another table in S-Flight schema and S-Flight model, travel agent. So the customer can be through travel agent dataset or the direct customer from the S-Flight schema for the customer's data itself. So I wanted to combine the customers from the own customers and also the customers who came from the travel agent database. So this is what it is happening. So and just in order to differentiate the data sets, I'm using type column, and I'm hard coding the value as a fixed value. If you remember the calculation view modeling, you can give a fixed value as a constant value to the output column. So it's going to always get all the data which comes from this data set will have agency as the type, and everything it comes as a direct customer. Okay, and that's it. I got my is there any error it is showing? Of course, I think it is showing some error. Let me get to the activation. No, isn't any error there. It's activated fine. And then you can also see that's union happening from these two data. I'm just making sure the ID column is the from S. So since I have a different column name for the agency name for the customer ID in travel agent table, I just made an alias to that. So it's going to be represented at ID. Other columns are same in both tables, so I'm just keeping the same. And that's it. I'm going to say data preview. And I'll get a most of them are direct customers, and I also have, let me see, I don't have this one. I can say agency as well. So these ones are the agency ones. These customer IDs 120, 190, and they some of them are direct customers who came from the direct customers to the company or enterprise. Okay, that's about union. Okay, and then you can do, yeah, as I said, you must be doing or spending at least some time in a union so that you will be able to understand different set operations which are designed in that particular document for your understanding purpose. Okay, so now the next topic I wanted to talk about is input parameters, and then we're going to move to the associations. This is going to be very important topic. I gave a brief starting point today, but I think I'll just going to leave this topic to the tomorrow's session. It's going to take at least an hour and a half. So we have a session tomorrow at 11 o'clock Eastern time. So we'll be covering associations in detail in tomorrow's session. Let me finish the input parameters topic, and then we will be going to the other topic tomorrow. So input parameters, the term you can describe or find the similarity between your native HANA CDS, or actually native HANA calculation view, where we define an input parameter, and then we pass the value to the input parameter from an external CDS view or reporting applications or whatever the case. Input parameters will pass the data values to the filters, to the functions, to the formulas, to the many objects inside the calculation view modeling. So it is not for filter for sure. Input parameter can be used for parameterizing your variables. Kind of a variables means dynamic values from the external applications or downstream, upstream applications, actually downstream, sorry. So with that context, so we're going to define an input parameter. Here at this time, we're going to define a very basic input parameter, and but over a period of time, we will be using a lot of input parameters in every example what we are going to use, because that's going to be really very mostly most common used object in the future. So we'll be understanding the syntax first today, and then we'll be spending some time in detail, not detail, in several use cases of input parameter from the value help perspective, from the other logical uses of the input parameters perspective, mapping from source one series to another series view, etc. Okay, so let's start with the examples 8 A, B, C. Actually, there are more than I've got 6 examples for defining the input parameters. So I'm going to talk about as much as I can, and then we can also do some exercises and say as part of the your exercise working sessions thing. Okay, so input parameters. I'm gonna go take this example 80A first. This is from finance model. Okay, I'll be creating new data definition. I'm going to say input parameter. I'll just give this simplified AXC1 input parameter example 1. Say next and say next and then finish it. You have the template for defining an input parameter. We have seen that, but we will not be using the template right now. We're going to define our own. Oops, sorry, 2 times I copy pasted. Okay, here also the same two standard um, parameters. So that's the standard annotations we are using. I'm going to say IP EX1. Okay, and then label, I'm just going to give the same name. I'm going to remove these two, and I'm going to define my view name. I'll go to the define view, and the view name has to be the data source, serial data source one. I'm going to give this IP exe1 x1 from, actually not from, I'm defining this view with parameters. So I'm going to use the syntax with parameters and just say, as if you get the prompt, just hit the tab, it's going to get you to that with parameters. And what are the parameters I'm going to use? So for example, I wanted to apply a parameter for country, so this is going to come as a input, sorry, it's just going to come as a parameter prompt to give the input there. So what I'm going to say, I will say IP, this is my parameter name. I'm going to say IP country, and then I'm going to say what type of this parameter is going to be. I'm going to define above data type and then say char. I'll say 5, 10, whatever the length maximum it can take. So that's it. So I got um, the the input parameter name and with the data type defined. So I can choose anything. And I wanted to give the label to it. I can also give the label to it. You know, the label can be given with end user text, right? That's a annotation. It can be for a column as well as anything. You know that end user text label is for any uh, CDS view or any column, or even for input parameter also. I'm going to say country as the label for this input. It's optional. You wanted to give it or you lose it. You don't want to give it. It's fine. Okay, and the description. So that's it. I have defined my input parameter with parameter statement, and then I'm going to say now as select from what. Then your regular syntax of SQL come into picture. So we have done this one already in the initial examples. I'm going to just copy paste from T011 to T05T for our example. Okay, up to the entire thing. So the only difference here I'm making is in the where class I'm specifying, I don't want to give this one here, I'm just removing it. Also I'm going to do the join condition is these two ones, okay, and I wanted to remove the whole thing in the bottom, and I'm saying in the where class just keeping the language as English, and I'm defining my other filter for the country column in my T001 table, but this time I'm not hard coding a specific country, but I'm choosing a parameter which is going to say parameters keyword, and then I wanted to give the parameter name. I didn't choose IP underscore land one. Instead I've given IP country. So I'm going to choose that. I can type in that, or I can say code completion. It's going to prompt me the input parameter currently defined in this particular CDS view. So this is done. It's clear. So activate it. This is done. Activated. You can see the message, and this is the symbol for input parameter. You can see that, and I'm going to run this now. Pen with data preview. Country. So I have to give the country um, US. These are the data records which are matched to the LAN one as US. This is the description as USA. I can also give other ones. when you run the actually the query, this is the parameter. Sorry, I wanted to refresh this and then say actually re-execute it. I just got to, let me close this one. Come on, my mouse has some problem. Open with data preview, and this time I may say CA. There's just one record with this country. Anyway, that's a simple thing what we can apply the filter dynamically. There are multiple examples I have given. Let's go to the second one. So in this case, what I'm doing here is calling the above CSV view from another CSV view. Here I don't want to run the um, run the CSV view and display the output. Instead, I wanted to call this CDS view which I just defined from another CDS view which is going to pass the parameter to it. So this is a calling procedure and called procedure. So you're going to pass the parameter value from one procedure to another procedure, same thing like that, or similar to what your calculation view passing one parameter to another parameter. This is going to be simple, very easy. So you just I can easily copy paste this one. I'll define a new one. I'm going to call this as ex2, passing input IP from CDS. Okay, and next, and then finished. I'll be just doing it. So I'm going to rename this one. Okay, and IP and ex2. And then I say that the CDS view name is going to be removed. I'll say underscore IP and ex2. And this time I'm going to use the CDS view which I just defined. I cannot use the SQL view in order to call my previously defined CDS view. So I remember my previous CDS view correctly. This is the one. So DDL source as well as the view name is same. So I'm going to use IP ex1. If this is CDS view is not there, it's going to complain. So it's saying that the entity I requires parameter IP country. This is what I've used. So I cannot use LAN1. So it was just giving IP country. Now it is good. And the rest I don't need to change anything, right? This is simple. This is done, activated. Now I can run this one, data preview, and it's going to get me only the US data. So what happened here is it is passing it is reading. This is my data source. This time my data source is a CDS view which I previously defined in the system, and it was expecting a parameter. So the CDS view was defined with a parameter. So you can actually just say code completion here. So it's going to ask you the IPXV. This is the data source, and then there is a parameter for that. IP country was the parameter. So let's just use that and these are the columns for that from that particular CDS view IPEXE1. So that's how I know I can give this parameter IP country, and then this is a character 10 data type. So I can give up to 10 characters for this one. Okay, and that's it. That's another example. So and you can go and see the other examples from other models, for example 8C. So here I'm saying input parameters for other columns. For example, distance. You want to apply the distance between two parameters. You can say one and two parameters. So, right, simple. You're defining with parameters, parameter one and parameter two. So you can have any number of parameters. It doesn't have to be just one parameter. So this series view is defined with multiple parameters. And when you're defining the data type, you didn't choose above data type, but instead you're seeing something else, s underscore distance. What is s underscore distance? It's a data element which describes. So if you go to the column of the distance, there is a distance column in SPLI. So it's going to be a data element for that, which describes the data type and length. So instead of defining above my own above data type, I'm just referring to the data element of that column, s underscore distance. So this is what it is here. So you can try this one, 8c, and then you can call this series view with other series view by passing these values, these parameters from the external series view, just which we have done there. And also from the other example, uh, yeah, this one we wanted to take a look at right now in a couple of minutes, and then understand this one. It's a very simple thing. System variables. Okay, I'll call the data definition, and I'm going to say CDS. Oh, actually, I'm going to say IPEX3. Um, example for what is that? System variables or system parameters you can call. Say next, and we're going to say finish. Control V, and then I'm going to say remove this one, IPEX3. I don't have to be having this one. I can remove it. And authorization checks also I don't have to be it. I just probably would have taken there. And then I'm going to name the series view. These are the minimum changes what I can do for the little time on it. And then I'm using a purchase order table as the source. I'm defining POID as the column, which is going to be purchase order ID. And I'm saying some of the standard system variables here. So session user. So you can see session user is your user, and then system date is your system date. This is like a site, some of the above old way to do define the client language and etc. So what I'm going to do, I can actually do the code completion, actually activation, and say data preview. Okay, open with data preview. So you can see the language is 8 as English, and then system client is 800, and the system user is ST HANA, and then system. These are the system variables you can use in your coding of the series view, just like how you use them size bar. So not size bars, this I use. I don't remember those above standard system environment variables. Here you can use these ones. There are more, you can find them from the guide documentation. So what I'm trying to example in this case here is use of these system variables in calling from other variable. For example, if you wanted to use the environment system variable, for example, language. So here I'm calling it as uh, p language as the parameter for which is defined here. So if we go into the p underscore language parameter, it's defined with the environment system. So you don't have to pass a value to the p language. So it's going to take the system language, which is going to be system language field from session, and it will be passed as a value to that input parameter, and it will get the English as the value, which is similarly if you're going to define system date as parameter, and you are getting the system date from the system date value instead of system language, and then that parameter is going to be applied on the date column, and then the, you know what I'm trying to say. Currently the language column applied here. Let's say you have a create date or a posting date here, and you can say posting date is equal to, and you can say environment dot system field and then system date. You can define that. So it's going to be up, the parameter will be passed with the system date current date to get applied on the filter class. So this is how you apply the filter for these environment variables. So you're going to define this one and apply the filters, pass the values without manual intervention. Here I'm going to just um, call the serious view with the system defined parameters as an input values. You don't have to define them manually or declare them manually. Okay, so this is how you can call. When you're calling, you just say system. This is how you define system language, and you're calling from another program. You're not passing any value manually, but instead you're saying session dot system language, and the system language will be passed to the P language, and the P language will be applied on this particular column, and then this whole view will be filtered for that particular language. Okay. Okay, that's about the input parameters in a very simple way, the basic understanding. And then in the next session, we're going to start with associations tomorrow, 11 o'clock. I've given the schedule to you. So I'll be taking a couple of questions here. See, can we debug the CDS views like above code? So this is the CDS view is not a program. This is a view definition. It's just one select statement. There is no multiple lines of code. This is one line of code. You are putting this code in 100 lines, but it is all together just one statement, just one line of code. So you don't do any. There is no point in going one to other step. There's no steps at all. So debugging means going from one step to another step. There is no steps involved, then there is no point in debug. I don't see the reason for going for a debugging itself. um, the code and your, yeah, these documents are going to be there in the training content which I'm uploading. It's going to be there. I see that input parameter is mandatory when you execute. I can change it to option. No, this, if you're using input parameter, you'll have to make sure you provide the value to it. Okay. I'm going to stop the recording first.